previous module, I was talking about sp hybridization, that you have seen that sp hybridization is formed by 1s and 2 pz orbital. I have taken. I have taken mostly pz orbital for the linear molecules, because that's the convention. But you can take any one. So you can take s and px and s and py. And from the treatment of sp hybridization, we found the wave functions for the two hybrid lobe as 1 by root 2 psi s plus psi px and psi pz, and then 1 by root 2 psi s minus psi 2 pz. Okay. So the wave functions was psi 1 was 1 by root 2 psi 2 p s plus psi 2 p z, and then wave function, second wave function was 1 by root 2 psi 2 p s minus psi 2 p z. The coefficients was 1 by root 2 and 1 by root 2. So if you talk about the contribution, then contribution is a square of the coefficients. So what you say, 1 by 2 is the contribution of psi 2 p s, and 1 by 2 is the contribution of psi 2 p z, and so therefore this is sp hybridization. There is sp hybridization, half contribution for both s and p. Okay, and after finding out the wave functions and the coefficients, what we did is that if we use the wave function psi 1 0 0 and psi 1 plus minus 1. Okay, and we found the angle of orientation of the sp hybridized lobes. Okay, so this was the previous module in which we talked about in detail about the sp hybridization. Now in this module we will talk about sp2 hybridization, which is formed by mixing of 1s and 2 p orbitals. And as you all know, from you have done it from your 10th standard, that when sp2 hybridization takes place, what we get is 3 hybrid lobes, and these 3 hybrid lobes are oriented in a single plane, and in this plane they make an angle of 120 degree. And so the shape is called triangular planar structure. The structure is called triangular planar structure. Okay, and it is this triangular planar structure where now you must have seen in some party that if you fill the balloons and you tie it together, it's the 3 balloons oriented at 120 degree angle. And you can do this at your home, and you can see that whenever you tie the 3 balloons, filled balloons, they will form a triangular planar structure. This is what happens with the hybrid orbitals also, and this we explain by I said you in the beginning of the hybridization that the theory which explains the structure of the hybrid lobes is valence shell electron pair repulsion theory, where we say that lone pair repulsion is much higher than lone pair bond pair, and then it's the weakest repulsion is bond pair. Here in this molecule, we suppose we don't have the lone pair. It's bond pair only. So all repulsion between H1 hybrid lobe H1 and H2, hybrid lobe H2 and H3, and hybrid lobe H3 and H1 will be same. So if there is a similar repulsion, then if you have 3 bonds, one in this direction, another in this direction, another third in this direction, like a pyramidal structure, then it will not sustain, because equally each one is repelling. So finally what it will have? It will form a triangular planar structure. Okay, so this will form a triangular planar structure. It's a natural tendency because of the bond pair repulsion. So that gives you the structure of the molecule. Now if you have this molecule where this hybrid lobe is representation by H1 orbital, H2 orbital and H3 orbital, okay, then what you can do is that you can write a wave function for the different psi H1s, suppose if I write, okay, then what I will write? I will write the coefficients A, then wave function of psi 2 ps. Thereafter what you will write? Plus another coefficients, okay, another coefficients, say B psi 2 p x I am writing. You can take any one, but x plus C psi 2py. Now we can replace B and C by, since we are talking about 2px and your h1 is along this red line, so the component of the x along h1 you can write from the vector equations. So that will be what? Cos theta 1 into cos theta 1 into psi 2px we can write. So, and if you have the theta 1 value, this you can write as cos theta 1 psi 2px. And if you have the theta 1 value, then you can get the coefficients of the second term, b value you can find out. Same way you can write the component of the psi 2py along h1. 2py is this one. So component of this along h1 you can write. Component of this you can along this you can write theta prime, and then you can write sin theta prime psi 2py here, and that will give you the c value. This way we can find out the different coefficients. But whenever you write psi h2, again you write psi 2ps, and this a remains a. Psi h3, this remains psi, sorry, it's not 2p, it's 2s. The first term is 2s, s orbital, so psi 2ps, this is also psi 2ps, and plus other terms. Similar way, depending upon the angle, you can write in terms of sin theta and cos theta the component along the hybrid lobe, and this way you can find out the value. In all this case, the coefficients of psi 2ps is a, because the contribution of s orbital will remain same to all the three hybrid orbitals. Okay. Now, if it is so, then what does it mean? Contribution comes from a square of the coefficients. So a cube, a 3a square is the contribution, and that will make equal to 1. So what will be the value of a? A will be value of 1 over root 3. So we found the contribution from coefficients of psi 2ps orbital also, and this way we can find the coefficients of psi 2px and psi 2py also. But instead of doing this and finding out this I am saying because only when you know the angles and only when you know that the hybrid lobes are oriented at this angle, this particular angle. Okay. Now, if you look at this one, from here to here, it is 120-degree angle. Okay. So what do you expect? What should be the angle of, and from here to here it is 120-degree angle. It's 120-degree angle, and from here to here you have 120-degree angle. Okay. Sorry, not there, here, 120-degree angle. And in between plus x and plus y, you know it's 90 degrees, so you can find the different angles and you can find out the coefficients. Okay. This is one way of finding out the coefficients, but we will not go by this one. We will use the traditional method, and we will first write the wave functions for different sp hybrid lobes. And these sp hybrid lobes we can represent as psi 1 as a1 psi s plus b1 psi px plus c1 psi py. Then c2 will be a2 psi s, b2 psi px and c2 psi 2py. So 2p I have not written, so it's px py only, or certainly it will be 2p. But it could be other also, but when I am talking about sp2 hybridization, it is 2px psi 2s psi 2px also you can write. Then psi 3 is equal to a3 psi s plus b3 psi px plus c3 psi py. We have taken px and py as contributing to the sp2 hybridization. It may not be px and py. If it is py and pz, the only difference will be that now the molecule will be in the yz plane. If it is x and z, then the molecule will be x and z plane. Nobody stops you from taking pz and px that you can take. Only the plane of the molecule will change. Okay. But so in sp2 hybridization, any two p orbitals can participate, and whatever orbitals participate, that gives you the plane of the molecule, in which the triangular planar structure you say, that triangular planar structure will be in that particular plane. Okay. Now our task again is to find out a1, a2, a3, b1, b2, b3 and c1, c2, c3. So one of the coefficients will remain same. I talked about just now, that since s orbital contributes equally, so the contribution is given by a square of the coefficients. So a1 square will be equal to a2 square will be equal to a3 square, and naturally since s is divided into 3 hybrid lobes, so the total contribution will be 1 by 3, and a1 is equal to a2 is equal to a3 will be root under 1 over root 3. Okay. So this I said you just now. So out of the 9 coefficients, 3 coefficients you found, it's a 1 by root 3. Now it comes determining the remaining 6 coefficients b1, b2, b3, c1, c2, c3. Okay. So for finding out b1, b2, b3, c1, c2, c3, what you do is, the first thing is that we assume one of the orbitals to be on the x-axis, and this is more easier way to do it, because here what I have done, here what I have done is that I have drawn the orbitals in between the axis. Now we say that no, instead of doing it in between the axis, you fix one of the lobe h1 on the x-axis, or designation you can do anything, h1 on the x-axis. The moment you fix the molecule on the h-axis, then the contribution of py becomes nil, because it's along the x-axis, so py does not contributes. And if py does not contributes, okay, then what does it mean? We are talking, it's h1, and h1 is a1, b1, c1. So the contribution of x-axis psi px is b1, the contribution of psi py is c1. So c1 will become 0. Okay. Since we have fixed psi1 along the x-axis, so contribution of py will be 0, and this contribution is actually c1 square will be 0, so c1 will be 0. Contribution is c1 square, and coefficient is c1, so c1 is equal to 0. And if the moment you say c1 is equal to 0, then the first wave function psi1 was a1 psi s plus b1 psi p psi px plus c1 psi pz. If you find out the normalization condition, again I did it earlier also, just for your convenience. If you find out the normalization constant, what it will be? It will a1 psi s plus b1 psi px plus c1 psi pz multiplied by a1 psi s plus b1 psi px plus c1 psi pz. Py. I have written py at one place, py. Okay. So it will be also py. And integral of this over whole space. If you find out the integral, what a1 psi s multiplied by a1 psi s will be what? a1 square psi s d tau plus b1 psi px, and b1 psi px will be, it's not equal to, it's plus b1 square, and then integral of psi px d tau, then integral of c1 square and integral of psi py d tau. You see all those terms where within the integral you have the similar functions psi px, psi py, and psi s I have written. You need not to write other terms, because other terms psi s, psi px, or psi s, psi py, or px, psi py, psi px, all will become 0 because of the orthogonality condition. But this integral is the normalization condition, and the psi s and psi px and psi py are orthonormal functions. So this will be equal to 1, and you will have a1 square plus b1 square plus c1 square is equal to 0. And c1 you have taken 0, assume 0. So from the normalization condition of psi1, you get a1 square plus b1 square is equal to 1. And a1 is known to you, a1 is 1 by root 3. So it will be 1 by root 3 means 1 by 3, b1 square will be 1 minus 1 by 3, and it will be b1 will be root under 2 by 3. So you have the two more coefficients, c1 is equal to 0 and b1 is equal to root 2 by 3. Okay. Now, similarly, as I have written normalization condition, you can write the orthogonality condition of psi 1 and psi 2 and psi 1 and psi 3. And from there you will get a1 a2 plus b1 b2. Say if I write, now I will not write the third term, psi 1 I have reduced to a1 psi s and b1 psi px. And psi 2 I will write all three terms, a2 psi s plus b2 psi px plus c2 psi py. So the integral psi 1 psi 2 d tau, it will be the orthogonality condition. And what will you get? A1 will be multiplied by A2. If A1 psi s plus B1 psi px is the psi 1 and psi 2 is A2 psi s plus B2 psi px plus C2 psi py. So A1 and A2 will multiply, A1 A2 psi s d tau. Then B1 and B2 will multiply plus B1 B2 psi px d tau. Okay, psi px d tau. So these two will be the only terms which is of importance, because this integral is an normalization integral and it will be equal to 1. Okay, so you will have a1 a2 plus b1 b2. Rest of the term, if you want a1 b2, then it will be psi s psi px and it will be 0. Integral will be psi s integral of psi s psi px will be 0. So all cross term I have not written. That's because of the orthogonality condition, that will become 0. So what you can write, a1 a2 plus b1 b2 is equal to 0, and out of this a1 is known to you, a2 is known to you, b1 is known to you. Okay, so all three terms is known to you. What you have to find out is b2 only. So b2 you can find out. This is from the orthogonality between psi 1 and psi 2. If you go for psi 1 and psi 3, then similarly you have a1 a3, b1 b3 is equal to 0. Out of this a1 is known, a3 is known, b1 is known, so b3 also you can find out. So b2 is minus a1 a2 by b1 and b3 is minus a1 a3 divided by b1. Okay, so a1 a2 and a3 are all same. What does it mean? b2 and b3 will be same, and the value of b2 and b3 will be minus 1 by root 6, minus 1 by root 6. Okay, so this also we found. B1. So now we have a1, a2, a3, b1, b2, b3 and c1. All these 4 plus 3, 7 values we have found. Now 2 coefficients remains. For the 2 coefficients, what you do? You write the normalization condition of psi 2. And psi 2 is a2 square plus b2 square plus c2 square. C1 value we know, c2 and c3 we don't know. Okay, so we are going to find out c2 and c3. So for the psi 2 function, same way, if you look at the normalization, you can write a2 square plus b2 square plus c2 square is equal to 1. Since a2 and b2 is already calculated, so c2 can be calculated, and if you calculate it, c2 comes out to be 1 by root 2. In case of normalization condition of C3, you get a similar equation, a3 square plus b3 square plus c3 square is equal to 1, and from here we calculate the C3, which is minus 1 by root 2. You will find plus minus 1 by root 2 here also, and plus minus 1 by root 2 here also. Just in order to differentiate between the two waves, in one case I have taken a positive root, in another case I have taken a negative root. Okay, so that's what, in order to differentiate psi 2 and psi 3, in one case positive root is chosen, and in another case negative root is chosen. Okay, that's everything I have written, so that you don't have any issue. Okay, once we have all the coefficients, now we can write the 3 functions along with the coefficients. Instead of a1, a2, b1, b2, I will write the coefficients, and the wave functions are psi 1 is equal to 1 over root 3 psi s plus 1 over root 2 by 3 psi px. Then psi 2 is equal to 1 by root 3. All you see, all psi s coefficients are 1 by root 3. Here it was plus c1 psi py, and since I fixed the one of the orbital h1 on the x-axis, So C1 becomes 0, you have only two terms, root 2 by 3 psi px. In rest of the functions, psi 2 and psi 3, the three terms are there. So it is minus 1 by root 6, minus 1 by root 6 is the term of B2 and B3. Then C2, C3 was plus minus 1 by root 2. So in one case you take plus root, in another case you take a negative root. Because if you take both by positive root, then you will not be able to differentiate psi 2 and psi 3. Both will represent the same function. So psi 2 and psi 3 are two different hybrid orbitals. So in one case a positive root, in another case a negative root is taken. Okay. Now I said you that the contribution comes from the contribution you calculate by squaring the coefficients. So if you want to know what is the contribution of s and p orbital, then what will you do? You will square the coefficients. In case of psi 1, the s contribution will come from the square of 1 by root 3. So if square of 1 by root 3 will be 1 by 3, and the contribution of p will come from the square of root 2 by 3. So it will be 2 by 3, and 1 by 3 plus 2 by 3 will make equal to 1. Okay. So the total contribution is 1, total hybrid lobes. Now you see, only 1/3 contribution comes from S and 2/3 comes from P, so it is SP2, psi 1, SP2 lobe. Look for the other functions. Psi 2. In case of psi 2, you have three coefficients, 1 by root 3, minus 1 by root 6, plus 1 by root 2. Okay. So what you can do, how you can calculate the contribution? So s orbital again is 1 by 3, but p orbital now has minus 1 by root 6 and plus 1 by root 2. So the square of minus 1 by root 6 square plus 1 by root 2 square will give you 1 by 6 plus 1 by 2, and again it will come out to be 2 by 3. So again 1/3 contribution from s orbital, 2/3 contribution from p orbital. So again it's sp2. In case of psi 3, the contribution of s orbital is 1 by root 3, so it is again 1 by 3, and the total contribution of p orbital is minus 1 by root 6, and what was C3? It was minus 1 by root 2, so minus 1 by root 2 square, and it is again 2 by 3. So you see that in every hybrid lobe, you have 1/3 contribution from psi s orbital, and 2/3 contribution from p orbital, and that's why it is an sp2 hybridization. Okay. So we proved that these equations represent sp2 hybridization. The next goal is to find out the angle between the hybrid lobes. That we know 120-degree angle, but how quantitatively we can know. And for knowing the quantitative value of the angle, what we use is the actual wave functions, spherical harmonics we use. The angular part of the wave functions of hydrogen atom we use. And if you remember, the y00 was actually root under 1 divided by 4 pi. y10 was actually root under 3 divided by 4 pi cos theta. y1 plus minus 1 was root under 3 divided by 4 pi sin theta sin phi, and y1 minus plus minus 1 was another function was root 3 by 4 pi sin theta sin phi sin theta cos phi. Okay. So we have these three functions. This is for the px orbital, this is for the py orbital. Now what we take, if you make it 1, then 1 by 4 pi will go from this function also, and this will become root 3 cos theta. 1 by 4 pi will go from here also, and this will become root 3 sin theta sin phi, that is py. And 1 by 4 pi will go from this function also, and that will be root 3 sin theta cos phi, that will be px function. So a relative value of the functions I have written here, not the actual value, relative value, but the theta and phi is there, so that will give you, only the constant becomes relative, rest of the terms with theta and phi doesn't change, so that will give you the angle. Okay. If you use this one, and if you put this value into the first orbital psi 1, then you see what do you get. In the xy plane, theta is equal to 90 degree, and so sin theta is equal to 1. So what is xy plane? If you remember the polar coordinates, it was z axis, it was x axis, it was y axis. Okay, and this was your r, and if you drop a perpendicular in the xy plane, we say, and then you join these 2 points, then the angle which it makes is with the phi angle. So in the xy plane, this is your z axis, this is your z axis, okay, and this is your xy plane. And if you have a point here, then draw a perpendicular from this point in the xy plane, and then see what angle it is making with the x axis. So angle in the xy plane will be phi angle, and the angle which this point, this r value is making with the positive z axis will be the theta angle. So if this is the theta angle, if this is your point r, then angle between my finger and this pen is the theta angle. And if it comes down and comes down with the finger in the xy plane, then the angle is 90 degree. So that's what it is written. In the xy plane, theta is equal to 90 degree. Okay. So if it is 90 degree, then sin theta is equal to 1. Okay. And what do you write? Psi 1 is equal to 1 by root 3. Okay. So the coefficient was 1 by root 3 psi s, and psi s I have taken as 1. So put 1, it will be 1 by root 3. Then you have root 2 by 3 psi px, because py contribution is 0. So px you have to write, and px is sin theta cos phi. So sin theta cos phi I have written. And then automatically it becomes 1 by root 3 plus root 2 cos phi. Okay. If you put psi 2 value, then again the first function will remain same, because psi s is equal to 1 by root 3 minus 1 by root 2 cos phi and plus root 3 by 2 sin phi. Again, you see all sin theta term will become equal to 1, because we are talking about the xy plane. Okay. And so it will become cos phi sin phi, and in psi 3 also will be 1 by root 3 minus 1 by root 2 cos phi with another 3 by 2 sin phi. So now the functions, quantitatively the functions are like this one. Now we have assumed one of the orbital on the x axis. So what you have to find out? In order to find the direction of the psi 2, you will find out the maxima of the psi 2, that where it's the maximum. And psi 2 is what? Psi 2 is just now calculated 1 by root 3 minus 1 by root 2 cos phi plus root 3 by 2 sin phi. And if you have to find the maxima, then what will you do? You will differentiate it with respect to phi. So if you differentiate it with respect to phi, what do you get? You get 1 by root 3 minus 1 by root 2 cos phi into root 3 divided by 2 sin phi. It's again the same function I have written. It's not d psi value. D psi value is here. Okay. So what I have written here, this function I can write. Actually I should have written here. It's the same function here. So I should have written here this function d and d phi. Now it's fine. Okay. So for differentiating, what you do is that you change this function as cos phi is equal to x, you write. If cos phi is equal to x, this you can write as, again I should have written d by d phi. Okay. Then 1 by root 3 minus 1 by root 2 cos phi is equal to x plus root 3 by 2, and now you have sin phi. So which I have written as 1 minus x square under root, because cos phi, so it will be 1 minus x cos square phi, and 1 minus cos square phi will be sin square phi, and if you take a root it will be sin phi. So I can write sin phi as 1 minus x square into phi. Now if you differentiate with respect to x, what will you write? If you differentiate with respect to x, the first term will go, and the second term will be this one, x into 1 minus x square 1 by 2. Okay. And this will be the differentiation, minus 1 by root 2 minus root 3 by 2 x into root under 1 minus x square, and finally what you get is you get sin theta divided by cos theta is equal to minus root 3 tan phi. Okay. So and if you find out the phi value, it comes out to be 120-degree angle. So we found the angle between the lobes. Means what we have found, what I said you, that if it is your xy plane, then I have put the psi 1 here or h1 here, whatever you want you can write. Then the next psi 2 will be at 120-degree from the psi 2. So psi 2 will be here. It's at 120-degree. Same way one can find the maxima of psi 3 also, and it will be phi angle will be 120-degree. Phi is the angle in the xy plane, so it's in the xy plane. In the xy plane, theta is equal to 90-degree, or so sin theta is equal to 1. That I have told you. Okay. So, if you put the value 120-degree angle, what is the value, actual value of psi 2 comes out to be? So, if you write cos 120-degree and sin 120-degree, what do you get? The value is 1.99. Okay. So, 1 by root 3 remains, 1 minus 1 by root 2 minus 1 by 2 plus root 3 by 2 and root 3 by 2. Okay. So, what do you get? You get 1 by root 3 and minus plus 2 root 2 plus root 3, and root 3 will be 3 and 2 root 2. And if you find the actual value, it comes out to be 1.99. Same way, if you find for putting these values, if you find for psi 1 value, so for psi 1 it's 1 by root 3 plus root 2 cos phi, and since psi 1 is along the x-axis and along the x-axis phi is 0, so cos phi is equal to 1, and hence it will be 1 by root 3 plus root 2, and that will be approximately the same value 1.991, and same will be the value of psi 3. So we say that we get equivalent hybrid lobes with the value of 1.99 and which are oriented along oriented in the one plane, that is xy plane, at an angle of 120-degree angle. So the fact which you already you were knowing, that sp2 hybridization gives you 3 equivalent hybrid orbitals which are oriented in a space in one plane, and they are at a 120-degree angle. We can explain through the just by using the orthogonality and normalization condition and writing the wave functions and finding out its coefficients. Okay. So that's all about sp2 hybridization. That gives you sp2 hybridization. So quantum mechanically, the qualitative concept which you were having, you can calculate it quantitatively and find the angle, find the value of these hybrid lobes, value of the coefficients, value of the eigenfunctions, everything you can find out. Okay. So in the next module, we will try to go a little further and we will talk about sp3 hybridization also. Okay. Thank you.